To get the sum of two functions, that's pretty straightforward. We just go ahead and add these two things, f of x plus g of x. So we'd have 5x squared minus 3x plus 6, and then plus the square root of x plus 2 minus 1. And really the only thing we can do here to simplify is to combine the 6 and the minus 1. Okay, that becomes a plus 5. And so we get our 5x squared minus 3x plus root x plus 2, and then plus our 5. For g minus f, this is g of x minus f of x. Well, we've got our function g, x squared of x plus 2 minus 1, and then we're subtracting f. And a very common mistake is that people forget to distribute that minus into the entire function. Okay, so I'm going to go and put parentheses here to indicate we're subtracting this entire function, and we're going to have to take that negative and we're going to have to distribute it to all three terms here. Okay, so we get the square root of x plus 2 minus 1 minus 5x squared plus 3x and minus 6. And now we can go ahead and combine this minus 1 and this minus 6 to be a minus 7. And we get root x plus 2 minus 5x squared plus 3x minus 7. For fg of x, that's just the product of f of x and g of x. F of x times g of x. Again, it's the entire thing, so we want to be careful in our notation. Go and put parentheses around the entire function to indicate that the whole function is what's being multiplied here. Okay. Now this is a pretty simple format that we have it written out and factored. If you wanted, you could go ahead and take this and distribute, but there's really no reason to do that because we wouldn't end up with any like terms to combine. So we'd end up with an expression that is just as complicated, if not more so, than what we see here. So I'm going to go ahead and leave it in this format. For f over g of x, well, that's f of x over g of x. And we can just go ahead and plug those in. So f of x is our 5x squared minus 3x plus 6 over g of x, which is square root of x plus 2 minus 1. And again, there's not really any reason that we should do anything with this. This form is about as simple as it can get. And now finally for part E, state the domain of f over g, so of this thing here. Well, we've got two things going on here. First of all, we've got this square root of something, okay? And when you're taking the square root of something, we know we can only take the square root of things that are greater than or equal to 0. So x plus 2, the thing we're taking the square root of, has to be greater than or equal to 0. In other words, x has to be greater than or equal to negative 2. We also are dividing here by that entire g function. So the entire thing that we're dividing by, square root of x plus 2 minus 1, this cannot equal 0. Well, now we add 1 to both sides and get that the square root of x plus 2 cannot equal 1. Square both sides, and that just gives us x plus 2 cannot equal 1. And then subtract 2 from both sides and get x cannot equal negative 1. And so now we've got these two restrictions, and so we're going to go just put those together to get our domain in interval notation. So starting at negative 2, inclusive, we go, but right at negative 1 we got to stop, okay, not include negative 1, and then pick up right after negative 1 and go to infinity.